My name is Ahmeti. I'm a threat researcher at Permiso Security, and today's talk is going to be inbox under siege. We're going to focus down on some real-world business email compromise attacks, where we're going to be focused on inbox rules.
Andi, është Andi Ahmeti nga Permiso, shumë të business email compromise. It's actually good. It's not easy.
Okay. Here's how we're going to spend the next 20 minutes. I'm going to start with a brief introduction about me. We're going to straight out jump to inbox rules, how they are being abused in the real world scenarios. We're going to talk about some obfuscation techniques, and we're going to have a summary at the end. So my name is Andi. I live in Prishtina, Kosovo. I'm a threat researcher at Permiso Security, and I've spent a good chunk of my career doing threat hunting and incident response, focusing on cloud security. While doing that, I've also had the opportunity to open source 3 frameworks. You can see them down at the end to help the community of cyber. Next on the agenda, the hidden weapon inbox rules.
Okay, he knew from the beginning.
Like I told him.
Okay. That was not me. So, just to do a quick zoom out, business email compromise remains still the number one or the most common used of attack. Why? Because email remains still the number one tool used in business communication. Now, usually start with initial access. So we have a phishing, emails, credentials are harvested through social engineering or buying credentials online, and the attacker has an initial access point. But now we're not just going to be talking the boring stuff of business email compromise. We're going to focus down on how inbox rules are being abused by attackers in real life. And to be honest, they are fairly used in all stages of attack. So on the reconnaissance phase, where the attacker is just reading out emails, forwarding them through to another external mailbox, or just hiding them, inbox rule can be used. Same goes for fraud and execution and completing missions. So inbox rules could be thought as a Swiss Army knife for attackers in this stage of the attack. But before diving in, let's just talk what are inbox rules. So they are self-managed by users in the endpoint, so you have them accessible on your mailbox. And they consist of 2 things. We have conditions, so what to look for, and actions, what to do after that condition is met. And some use case scenarios for automation are moving emails from a folder to another folder, forwarding them to another mailbox or externally, and just deleting them. You can interact with them throughout the Outlook web application, throughout the thick client, and the PowerShell Exchange module, which we're going to use for some obfuscation techniques. Next, we have transport rules. Now, transport rules are configured by the administrators at the tenant level, and they do run before messages arrive. Now, transport rules are used often to enforce organization policies, and to meet the compliance and security. You can interact with them throughout the PowerShell Exchange module at the Exchange Admin Center. Now, how they are being abused in the real life, we have an example of a breach. So first, the attacker successfully logs into the mailbox, possibly using stolen credentials via phishing, social engineering, or buying them. Next, we have a reconnaissance phase, where they retrieve 170 emails. So they're trying to get further insights into the organization, know who's the CEO, who's the security team, reconnaissance stuff that each attacker does. They do an action, so they have moved an email from the junk folder to the inbox folder. And that can be easily done vice versa. So they try to hide their trail. They're trying to make that junk email that they got initial access was normal. And at the end, you have the new inbox rule. So if we stop just a bit at the new inbox rule, what does make an inbox rule suspicious? We have the suspicion scale over here. So first, the inbox rule is deleting emails. Okay, let's give it a point of 2. It might be normal. In our case, we have 2 points. Now we have another flag, which is stop processing rules. Now what this does, that it says to the inbox rule, you have the top number 1 priority, and you will override any previous rules that are created. Next, we have the received after date. Now, this is a condition, and it's odd being used by normal users because it's essentially deleting any future emails at a certain date. And the date was the initial the date that the attacker got initial access. So essentially it's deleting everything that comes after that date. And last but not least, we have a really suspicious rule name, which is a random string. It's stored like DSBVG. So it's not a rule name which a normal user would create, which raises our suspicion scale to 9.0, and we can flag this inbox rule as malicious. Same goes for another use case, where the attacker just straight out deleted everything, and again we have the rule name with a dot, a comma, semicolon, so it's just an unusual rule name, and it could be a good or a strong indicator for compromise. Now, this is a query, a KQL query, and I like to call this now the low-hanging fruit level of detection, and we're going to see why on the later slides. Now, what this query is doing is essentially checking for any new inbox rule created or modified, which contains any of the following credentials, and if any of the following, conditions, so subject contains words, subject or body, and body contains words, if any of these following conditions have either of these keywords, then just flag this one, because we're for sure, if you're an IT or security team and you're sending a security email to the victim's mailbox saying, hey, your account has been compromised or your password was changed or any admin stuff, this email would get deleted. But we're going to see later on slides how we obfuscated inbox rules and bypassed them. So we're going to the spicy stuff. I like to separate the obfuscation techniques into two main buckets. So we have the functional obfuscation techniques, and that's basically obfuscating how inbox rule works, so their functional aspect. We have the syntactical obfuscation techniques, and we have both condition and actions, because they both can be obfuscated to bypass detections, and we have some last obfuscation party favors and how to evade locks completely. The first one, my favorite, is using the humble null character. Now, this is the syntax on PowerShell of creating a new inbox rule. Again, it consists of having a mailbox, a name, a condition, which in this case is body contains words, so the body of the email, and the action will be moved to folder deleted items. But now, we're going to insert a null character in both the name and the condition. So this is the null character. It could be also replaced with the \U40. And what's interesting about this inbox rule is that the rule name, it doesn't appear as a null character, so this is the rule name. It actually appears as a random number with a dash in front of it. And what's even more and more interesting is the warning message which you get after creating the rule, which says, this certain rule contains errors, and in order to resolve those errors, please edit the rule or recreate it. Okay, in our mind, we think that this rule should not be working, right? We have a warning message. If we query deeper, we see that the error type is internal error. And as soon as you see this, you say, okay, this inbox rule might not work. We jump into the UI. Again, this is the UI outlook for inbox rules. And it says that the toggle button is grayed out. Shouldn't be working, right? Again, we have the warning message, which we got earlier at runtime logs, which says this inbox rule is containing some errors. But the interesting part, or the catch here, is that this rule actually works. It does work on the background, so Exchange accepts it. But because we put the null character to the condition, it's displaying some kind of warning. Again, this is a warning. It doesn't say critical error, but it's just a warning. And, okay, this rule is working, but for what condition? We put the body contains word to null character. Do we need to put the null character to an email for this rule to actually work? No. Actually, Exchange, what it's doing, come on. Okay, so what Exchange is actually doing is accepting the null character and is translating to say apply to all messages. So now this rule will apply to all messages. So I'm referring to messages as emails in this context. So this rule will apply to all emails that come to your victim's mailbox, and then they will get deleted. But now, where's the detection part of aiding? You can see on the right side, this is the audit logging for Exchange, and on the condition, we actually have the null representation. So we have the /U40, so this is the null Unicode representation of null character. And in our case, as Okay, sorry. So, okay, amen. So in our previous detection, which we just mentioned, we will be looking for apply to all messages, but we got Unicode. So our detection would fail, and this inbox rule will delete any future emails that come to this mailbox. Now let's use the null character in other scenarios. In this case, we're having another condition which is subject, so the subject of the email, or body contains words. So if the subject of the email or the body is containing the null character, let's just move it to the deleted items folder. Now, not only we get the warning message, we also get a double red pipe over here, indicating that something went wrong. And what's interesting is that this rule is actually pre-destructive, because if we go to the UI, we actually see that inbox rules service suddenly becomes ineffective, unviewable, unretrievable. On the right side, we have the thick line, so the outlook. You can see that it says like we couldn't get a list of your rules. Same goes for the UI, and also we have our error code of 500 down here saying corrupt data exception. So essentially Exchange, inbox rules are broken and you cannot view with them, and we still haven't found a solution on how to actually get them back. Next is where we deceive the detection by adding a couple of, let's call them trash characters. In this case, we have the zero width character. Now, the zero width character is essentially a zero width character, as it says, so it has zero padding, and it's used for line control break. But we thought, okay, let's use it. Now, we have the condition of admin, but we inserted a null character between the letter D and M. We said, okay, let's see what happens. We see that on the UI, actually, it gets accepted as the word admin, but we are sure that we also added another character over there. So, as you can see on the Graph API logs, so this is the Graph API we're querying for this inbox rule, it does show an extra space over here, however, it doesn't show that on the UI. And the funny thing about this is that it actually works. You just have to send an email where the word admin, or the keyword admin, it could be password security, it doesn't matter, it's just a proof of concept. The inbox rule would catch that, since Exchange does strip out the invisible character, but on logs, it doesn't show that. It gives us that yellow square bracket, indicating that there's another character over there. And what this does is it actually breaks our previous detection, which I called it low hanging fruit level of detection, because we are doing string literal query matching. So we are literally asking for just the admin keyword. But on logs, we have the admin and another extra character. So this rule wouldn't fire, and on Exchange is perfectly working, and it's filtering down on keywords of admin. Another subset of Unicode is obfuscation, is the mathematical alphanumeric symbols. Now, I know you might not have heard of it. So essentially, these are fonts, let's call them that way, which mathematicians use to write variables or whatever mathematicians do, or physicians. So we said, okay, it looks like the word admin, because to our eyes we can read them, but to a system, again, who's doing that previous query, or any query which is doing string literal query matching, it would get bypassed because this word is a completely different Unicode point. I've tried this one. We did create an inbox rule, again, with these Unicode points, and we have the keyword of admin, so they are readable to our eyes. The inbox rule gets created. You can see on Graph API is that Frankenstein-looking keyword admin. Also on the UI, you can see that it does show up as admin. Same goes for logging. So this is the audit logs we got on our SIEM. So it says admin. But the funny stuff is that, again, the inbox rules, or the Exchange, is doing some sort of translation. So if you just send an email containing the normal admin, again, you don't have to write these funky characters. All it needs is the actual Latin characters of admin on your keyboard for this inbox rule to get triggered and to delete any emails. Again, the previous detection gets bypassed. Now, we also done the lookalike characters. Now, this is not just doing character swapping, it's actually creating visual confusing. So what I did here is that I found a subset of letters. For example, this little r is like on math when you have the exponent on top. Now, we put the letter r over there. So what we are attempting with the inbox rule is deleting any emails containing the word breach. Okay? But we use a little r there. And what we did here is that to a defender or at 2 a.m., this word, or form of r, I don't know if you can see the little r there, it looks like a word beach. So it might sound that the inbox rule is actually deleting words of beach, but it's essentially what it's doing is parsing it as breach, and any emails containing this word will get deleted. And again, the previous detection fails. Why? Because the letter r is not the normal ASCII character. It has a different Unicode point to a system. Now, this is the directional formatting characters. Now, there are a subset of characters which I'll call directional formatting. And what they do is they just change the way, the rendering order on the UI, but it doesn't affect the actual logical text. I'm going to explain that later on slides. Now, there are 4 subsets of categories. We have the overrides, isolate, embeddings, and marks. But I'm going to do just the overrides. So if you have a word Prishtina, and we put the right to left character over here, so this is the Unicode point for the right to left character, and we do that, we're going to see that the actual word was changed the order. So this is how it looks on the UI. But it's actually the logical or the actual meaning of it still stays as Prishtina. Now, I do have is someone here? I have a demo over here, but I don't know if that's working. Okay. Okay, nice. So I'm doing this on demo. We see that on this mailbox we have no rules created, nothing to interfere. This is the syntax of creating a new inbox rule. And we are specifically adding 4 keywords: the admin, password, reset, and security. And we can be generous with the amount of keyword we add here. And in each of them, we have inserted the right to left character over here. Now, we hit create, and the action is delete message. We've hit create, and we see that when we query for this inbox rule, again, on the description, it shows that if the message includes any of these words, admin, password, reset, and security, delete. But you see this funky looking diamond-shaped question mark, and you might think this shouldn't work. But this is how CLI represents this. On the UI, if you see on the description, after the subject body, everything is just as you put a reverse card in it. And on the conditions, you have animed, pass draw, rest, security. So nothing like the actual word we are intending or keywords we are intending to delete. But now let's just try this. So this is a security email. It says security alert, admin, password, reset, activity detected. So we're putting all 4 of our keywords, and they are normal looking keywords. Like you don't need to put those right to left characters in order for this inbox rule to fire. So this is a general security email, and we hit send for that email. We see again we have 1 inbox rule. It's just the one that we created earlier, and after some seconds we should be seeing the deleted item number 1, which says that this email never reached the inbox. It was actually deleted because it has those 4 keywords. But essentially, those keywords on the UI, they show a different word because that right to left character is changing their rendering offer. On the CLI, they also have that bad character U202E. So it would break detection, and it would create also visual confusing for any defender or the actual victim user checking that inbox rule. Next, my favorite one is if you move emails to a deleted items folder, to the junk folder, or another folder archive, these paths should be highly monitored by defenders because it's what the attackers actually do. But we said, okay, let's try to move them to another folder. And we saw that the calendar, the actual calendar, if you use Teams or the Outlook, where you see emails, is considered a folder in Outlook. We said, okay, what if we say, and we create an inbox rule, which says, if the condition of admin is met, let's just move emails to a calendar folder. Let's see what happens. And that actually worked. And as soon as that email lands on the calendar folder, good luck. Okay, come on. Good luck retrieving it, because Exchange simply doesn't render the email to your calendar. You're supposed to see meetings or whatever, but not emails. So essentially it becomes a black hole for emails, where emails just go there and you cannot retrieve them. And I would be surprised or happy to know if someone finds a way how to actually view that email, because it simply doesn't work that way. Now there are other emails. You can forward emails to the contacts folder or the journal outbooks. All 4 of them did work. And at the end, if you're a defender, normalize everything. So strip out invincibles, those bad characters, and try to do a differentiation between a raw output logs and the normalized. And at the end, don't just hunt for keywords, hunt for rule actions, because that's what matters, because the action matters in this case. So check for moving to an unusual folder, like the calendar, the deleted items, the archive, anywhere where the user is not actively checking that folder. Check if the emails are being forwarded externally to another mailbox, and also check for how to delete. If you're too busy to do this, I've just released last week my open source tool at Blue Team Con Chicago. It's called, it's called Inboxfuscation. So if you're a red teamer or a blue teamer, you can use this framework to generate or simulate similar obfuscated inbox rules. And also you have the find obfuscated inbox rule to check if any of these suspicious inbox rules are present in your environment and generate a report from that. 3 main takeaways: understand how inbox rules are being abused in the wild. Definitely recognize how Unicode obfuscation can evade traditional security. And last but not least, use Inboxfuscation, which is a brand new open source framework where you can simulate, detect, and remediate obfuscated rules. And with that, I would just want to say thank you for your time. It's always a pleasure presenting at BSides Tirana.